Hello, is my screen showing and my voice all clear? Please let me know if I'm audible.
Yep, all good.
Okay, so I guess we can start now. Welcome everyone. Welcome to another session of Statistic for Machine Learning, AI, and Data Science. This is the day 4 of this community session. And let me just quickly introduce myself. Hey guys, I'm Transa Rosa. I'm currently studying in Brack University and this is my third year. So without any further ado, let's get started. So in today's session, these are the topics we're going to cover. We're going to cover measure of position. In measure of position, we have percentile, quartile, decile. Then we will move to range and IQR. Then we will talk about five number theory, and then we will, by covering this topic, we will understand the box and whisker plot, and then we will see some Python code, and then we will cover the covariance and correlation. So let's start with measure of position. Guys, do you know what is measure of position? So in statistical concept, measure of position is used to divide a dataset into equal sized subgroups or interval to help us understand the distribution of data. Um, so measure of position, which is also known as quantile. So by measure of position, what we will understand? We will understand the the distribution of data, the position of data sets. So in measure of position, we have percentile, quartile, and decile. So let's get firstly let's get to percentile. Okay, before that, let me show you a dataset. Suppose this is your dataset, which has numbers like 1, 1, 2, 4, 5, 5, 5, 6, then 7, 7, 7, 7, and 7, and let's say 8, 9, 9, 10, um, 11, 11, 13, and 14. So the total number in this data set is 20, so n equal to 20. So if I ask you what is the percentile of ranking 11, if I ask you what is the percentile of ranking 11, how you will get the answer? Okay, before that, let me make you understand what is percentile. So percentile in percentile, we divide the dataset. We divide the dataset into 100 equal parts. So this is our data set, and then we are going to divide this data set into 100 equal parts. So to make you percentile understand clearly, I am going to answer this question. What is the percentile of ranking 11? So to find the percentile of ranking 11, we have a formula, which is, firstly we have to find the total number below 11. So we have to find x, which is the total number below the number which is asked in the question, which is 11. the total number below 11. So we have to count first what is the total number below 11. So in our data set, if we sort this thing ascendically, this is our 11. And below 11, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. Okay. Um, so this is 17. So the formula will be something like 17 by the total number in the data set. The total number in the data set is what? 20. So n equal to 20 into 100%. So by calculating this, we get 17 by 20 into 100. We get 85. So you know what this 85 means? It means 85 of the entire distribution, or 85 of the 85% of the values in the data set are less than the value, which is 11. So this means 85 percentage of the values in the data set are less than 11. So do you get my point? By percentile, we get the percentage that how much how much how much percentage of data is below that number that is given in the question. So if we think inversely, suppose suppose you are told to find the 25th percentile. Okay. So in this case, you have to find the value. You have to find the value below which the 21st to 25% of the entire data set lies. You have to find that value below which 25% of the data set lies. So to find that, before finding that, we have to find the index of the value. So firstly, we have to find the index equal to percentile by 100 into n plus 1. This is the formula. So in this case, n is 20. As I said, there are 20 numbers in the data set, and the percentile is given, which is what? Which is 25. So if you calculate it, 25 by 100 into 21, 20 plus 20, 20 plus 1, and the answer will be 25 by 100 into 21. You will be given 5.25 index. So go back to your data set and find the 5.25 index. You cannot find the float number, right? So you go 1, 2, 3, 4, 5, and 5.25 means something between this. So you have 5. So what does it mean? 25 percentage of the values of entire data set are less than 5. 25% of the values of entire dataset are below 5. You see, if this is if you consider this dataset to be 100%, so 25% of the dataset is below 5. So this was from percentile. Now we are going to learn how to calculate this percentile using Python code. This is very simple. Okay. So guys, you can see my screen, I hope. This is the dataset that we used previously. So we just checked if the length is okay, n equal to length of dataset, which will give us 20. So the same question, find the 25th percentile and how to calculate the answer. Firstly, you have to write np.percentile. Now, what does that np mean? NP stands for numpy. It is written in short form of numpy. Numpy is a library of Python which calculates the difficult matrices and all that thing, difficult matrix calculation. Numerical numpy stands for numerical Python. So firstly, you have to import numpy. In this case, we have imported numpy. Import numpy as np. We use this as function to shorten numpy. Now, np.percentile, what do we want to find? We want to find the percentile. In this parameter, we have to give two arguments. One is the dataset and one is the number of percentile. So we pass the dataset, which is this dataset, and we are passing the percentile, which is 25, and the answer is giving us 5. And you can see we also got 5 from here. So this is the way we can find this answer using Python code. All right. Any questions so far? Guys, do you understand? Any questions so far? Or should we move to the next topic? Okay, I think we can move to the next topic. So the next topic is quartile. Before moving to quartile, let's talk about median. In the previous sessions, we talked about median, right? So what does actually the median means? Median means the center value of a dataset. Suppose this is your dataset in a number line and your median will be the exact center value. So this is your median. So to find your median, you have to go all the way, half the way through your dataset. You're going half the way in your dataset and you will find your median over here, right? So in quartile, we divide the data quarterly. We divide the dataset quarterly, which means if we consider this data, that this is the 100% of the data, we will divide 4 parts. So suppose 0 and 0 percentage of the data, 24 percentage of the data, 50% of the data, then 75% of the data, and then you have 100% of the data. This is how you are going to divide the whole data into 4 parts. So let's draw this thing again. This is your entire dataset in a number line, and this is your median, the middle value, the center value of your dataset. And you want to divide it in 4 parts, so you will divide this part equally and this part equally. So what does quartile mean? As I said, quartile is in quartile we divide the dataset quarterly or in 4 parts. So after dividing the whole dataset into 4 parts, This is your quartile 1, but Q1, this is your Q3, and the median is your Q2. Guys, relate this thing to the percentile concept we just learned. Uh, that below Q1 you got 25% of your data, below Q2 you have 50% of your data, below Q3 you have 100% of your data, or below Q3 you have 75% of your data. And what is the lowest and the highest value of any data set? The lowest value is known as min and the highest value is known as max, right? So to understand this concept more clearly, we are going to learn range and interquartile range. Before that, let me shortly just tell you what does decile mean. In decile, you divide the dataset into equal 10 parts. You mainly need these two parts. Okay, so let's understand what is range. Okay, let's talk about a dataset. Okay, suppose this is your dataset where you have 2, 5, 6, 8, 10, and 14, a very small data set to make this thing understand very easily. So in this data set, what should be your Q1, or what should be your median, or what should be your Q3? Can anyone tell me? Okay, so in this data set, if we divide this into 4 parts equally, suppose two, three, four, five, six, seven, Q3, 6 is your Q2. Okay. Yes, you divided your dataset into 4 equal parts, and after dividing it, you have your Q1, your median, which is Q2, and your quartile 3, which is 10. So if you calculate the range, you know how to calculate the range. You have to just have to subtract the maximum from subtract the minimum from the maximum value. So the maximum value is 14 here, and your minimum value is 1 over here. So to find the range, you will just subtract it, 14 minus 1, which is 13. And in interquartile range, IQR, you have to subtract Q3 minus Q2, Q1. So in this case, your Q3 is 10 and your Q1 is 2. So you get 8. But if I replace this value with an outlier, then the case will be very different. Suppose I'm replacing this value with an outlier. You know what is an outlier? An outlier is a number that is significantly bigger from the other distribution in your dataset. Suppose in this case, if we write 60, this should be your outlier because this is significantly big than your other dataset, other values in the dataset, right? So in this case, if we want to calculate the range will be 60 minus 2, which is 58, and the interquartile range IQR will be Q3 minus Q1, which will be, again, what was the Q1? This is the Q1, and this is the Q3, and this is the Q2, the middle or central value. The value will be 10 minus 2, which is equal to 8. See, in this case, after finding the range, you see the data are very spread it. By the range, you will understand that your data in your data sets are very spread it. Like 58, you see the minimum value is 2 and the maximum value is 60. So by this thing, you have an idea that your data set is very widely spread it. But in reality, there is only 160, and the other number in your data set aren't that spread it around. Those are quite tightly around the mean. You see, 2, 2, 5, 6, 8, 10. These are situated pretty closely, but this gives a false idea. The range, by finding the range, we are getting a false idea that our data set is very widely distributed. So why we don't use range and why we use IQR or interquartile range? This gives us a fair idea about the distribution of our dataset. You see, the IQR is also 8 in this case, and in this case it is also 8, and it gives a proper idea about our dataset. So by using interquartile range, we get a proper idea about our dataset, proper idea about the distribution of our dataset. And by IQR or interquartile range, you can also find the outlier. Now let's move to that. So how can we find the outlier using IQR? And in this part, we will also talk about the box plot and whisker plot. I just want to quickly ask, is everything clear so far? If you have any questions, you may ask. Okay, I think we can move forward. If you have any question, you can unmute yourself and ask. All right. So let's again take a data set. Let's say your data set is in of total 20 numbers, and it starts from 1, 2, 4, 5, 5, 5, 6, 7, 7, 7. We are using the previous data set. 8, 9, 9, 10, 11, 11, 13, 14, and 16, the outlier one. And we are going to see how we can find the outlier using box and whisker plot. Okay, uh, in this topic, we are also going to be introduced to 5-number theory, 5-number summary. I'm sorry. All right, so to find the box plot or whisker plot, firstly you have to build this intuition. Suppose this is your data set and you want to find two fence, or you can also call it boundary. One is known as lower boundary and another one is known as higher boundary or higher fence. Anything you want to say? Higher boundary. So by getting the lower boundary and higher boundary, you will get to know about the outliers in your data set. Any number below your lower boundary and any number below above your higher boundary will be considered as outliers. So let's just do it. Let's solve this math and get your intuition clear. So firstly, we have to get the value of these two, lower boundary and higher boundary. The formula of lower boundary is quartile 1 minus 1.5 into IQR, and the higher boundaries formula is Q3 plus 1.5 into IQR. Okay. After that, what are you going to do? So to find the lower boundary, firstly you have to find the Q1, as we don't know what is our Q1, and then we have to find our Q3, and lastly we have to find the IQR or interquartile range. So firstly, to find Q1, just like in previous how we solved the Q1, we will use the same method. So to solve Q1, first we have to find the index. So index equal to what we have to write here, the percentile. We know that the Q1 covers below the Q1 25% of the data set are there. So Q1, the percentile will be 25% for Q1. And can anyone tell me what will be the percentage of Q3? It will be 75%. So in the formula where we have to write the percentile and then yes, the 100 into total number of data set, which is n plus 1. So for Q1, the percentile is 2500. The total number in this data set is 20. So 20 plus 1 is equal to 21. And we are getting 5 as answer. So we will find the fifth index from our data set. Let's find the fifth index. 1, 2, 3, 4, 5. The fifth index is 5. So this is our Q1 of our data set. Okay. So Q1 is equal to 5. Now let's move to Q3 and let's find what is the value of Q3. So firstly, let's find the index. Index equal to 75 by 100 into n plus 1, and n will be 20, and by adding 1 it will be 21, and you get your value as 15. So we have to find the 15th index from our dataset. Let's go up and find the 15th index. Okay, so 1, 2, 3, 4, 5. So this is our 15th index, right? 1, 2, 3, 4, 5. Okay. No, this is our 16th index. We will find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 10 is our 15th index. So I is equal to 10. 10 is the value. So this is our I3. and we know how to find the IQR. IQR equal to Q3 minus Q1, which is 10 minus 5 equal to 5. Now let's find the lower boundary and the higher boundary. The lower boundary equal to 5 minus 1.5, the value of interquartile range, which is 5, and the higher boundary is equal to 10 plus 1.5 into 5. Okay, so let me just quickly calculate it. 5 into 1.5 into 5, we have minus 2.5. And in this part, we have 10. 10 plus 1.5 into 5, which is equal to 17.5. So guys, we got our lower and upper boundary. So suppose minus 2.5, and there we go with 17.5. What does it mean? It means anything smaller than minus 2.5 and anything above 17.5 should be considered as outlier. Now we have to find our outliers, right? So this is our fence, and to find our outlier, we have to find some other things. Okay, let me quickly tell you what is the 5-number summary. These all are interrelated. So in 5-number summary, you will find the idea about your distribution. It provides a concise summary of the dataset distribution. By this summary, you will know the central tendency, the spread, and the shape of dataset distribution. So in 5-number summary, you have to find your mean, your Q1, your Q2, which is also known as the median, and your Q3, and lastly, the maximum value in your dataset. Not in your dataset, between this range, okay? So firstly, let's find the minimum value. We see the boundary is minus 1.2, so we can consider 1 as our minimum value. Suppose if the boundary was 7 as the lower boundary, then we had to choose 7 as our minimum value. Guys, you get my point? We have to choose the minimum and maximum after setting that boundary, setting that range. So one is our minimum value here, and we found Q1 already, which is what, 5. Let's find the median. The median should be the central value, which is, you can clearly see we have a lot of 7 here. So if we count from 1 to 10, we will have 7 as our median, and we got Q3 as 10, and now the maximum value. Guys, can you tell me what can be the maximum value? The upper boundary is 17.5. The upper boundary is 17.5. So what can be the maximum value? Any idea? Okay. So the maximum value, since the upper boundary is 17.5, this is our range. Suppose it was from minus 2.5, something from here, and it will go all the way to 17.5. So the maximum value will be 14, not 60, because it is outside of the range. So the maximum value will be 14 here. Now we can draw the box plot and Whisker plot. This is our whisk. This two part means the minimum and maximum number. In this case, the minimum number is 1. So suppose this is our number line. So the minimum number will be 1. And in this case, our maximum number is 14. So this should be 14. Okay. And it started from minus 2, right? Minus 2.5. So let's say minus 2.5 minus, we have 0, then let's say 3, 5, 7, 9, 11, 13. It's uneven, but I think you get my point. This is the number line. And then we will have after 14, let's say, acha, let's move 14 from here. And after 13, we have 15, 15, and then we have 17. Excuse me, please. Okay. Just a second, please, guys. Okay, I think we can continue. Just a second, please. Let me just fix it. It's giving me some issues. Okay, let's draw it from the beginning. Let's say this is your number line. Uh, you have to first put your lower fence, which was minus 2.5. Then you have, then say, let's say you have 0, then we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and it goes on and on and on. Alright. So your lower fence was 0. Minus 2.5 and your upper fence was 17.5. Now you have to find the minimum value. Your minimum value is 1. So it is somewhere between this part. So we will draw the one part, the left part of your whisk, and the maximum value is 14. So we have to draw another part of your whisk, which is the maximum value. Now you have to find the Q1. The Q1 is 5. So let's draw your Q1 here, and your Q3 is 10, and your median or the middle value of the distribution is Q2, which is here. So this is Q2, this is Q1, this is Q3, this is the minimum number, this is the maximum number. So your Q1, Q2, Q3, minimum, maximum number, you got all of this. But you see, you had another number which is 60, and the 60 does not fall under the range. The 60 does not fall under minus 2.5 to 17.5. So in this dataset, the number 60 is considered as outlier. So in this case, the number 60 is considered as outlier. In your code, the the graph will be something like that. You will get this thing, and then for the 60, you will get some values like under the 60. Hmm, Not multiple, only one value because there is only one outlier in this case. Suppose you had a lot of outliers. Suppose your data set, suppose if you had minus 4.5 or minus 7, minus 7.5, minus 7 in your data set, these values would also be considered as outlier, and you would get some points over here. So this graph is known as your box plot, box or whisker plot. And by box or whisker plot, what you what do you get? You get the intuition of the outlier in your dataset. So this was the part. Now we are going to see the Python code for this. Before that, guys, can you tell me if you are okay with all the things that I've said? Do you have any confusion? If you have, you can unmute yourself and ask. All right. Okay, let's move the next part. So you see this was our data, and to find the box plot, we will be writing this block of code. So let's understand what is here. This is firstly we have to import the matplotlib.pyplot library from our from here. This is also a Python library. For matplotlib, we usually visualize the data. So firstly, here is our data set. And to create the box plot, firstly we have to write plt.figure. The plt is the short form of pyplot. plt.figure, so you will get a box like this, writing this code. And to find the box plot, this is very easy. You just have to write plt.boxplot, and then you have to pass two parameter. One is your data, and another one is, you can also ignore this, vertical equal to false, which means your which means your graph will be horizontally there. If it was true or it was removed, you would get a different picture here. You see, you'd get it vertically, but we don't want that. I think this way this looks more good. So you see, in the in the spot of 60, we get the data point, which is our outlier. And yeah, here is our minimum value, here is our maximum value, and this is our median value, and this is the Q1 quartile 1, and this is the Q3 or quartile 3. And uh, you can write plt.title, which is the title of this graph, which is box plot of sample data. Then x label, you can label something here. We have labeled value, so here we have it. And then we have, then if you write plt.show, this plot will be shown. So almost this was it. You can get your box plot writing this block of code. You can do this many ways. You see, this was a very small data set, right? But what we will do when you have a large data set, the whole thing is the same. Just one thing you have to do different is you have to get the data set from your CSV file, or from any URL, or from your local storage. I mean, uh, suppose from your notepad, from your Excel sheet, you have to just extract your data and get your data, and the rest of the codes are same. So in this case, we use the Titanic data, and to derive this Titanic data set, we imported the Seaborn library. So Titanic data equal to SNS, the Seaborn's short form as SNS. You have to write load dataset by writing load dataset and passing the value over here, Titanic. you get the Titanic dataset, and after that the same code block, and you get the similar box plot. But yes, the datasets are different, so you have a lot of outliers over here, right? Okay. And yes, this is another way you can find your percentile, decile, interquartile range. These things are very easy. I will share the IPYNB file with you guys. But since we don't have much time, let's quickly move to the next topic, which is covariance and correlation. Before that, guys, I want to ask, if you guys have any question, please let me know. um Am I going too fast, too slow? Please let me know if you have any questions. Okay, I think we can move to the next part as we don't have much time. So the next part is very easy, which is covariance. Suppose let me make you understand the covariance term with an example, right? Suppose these are the data of x-axis and these are the data of y-axis, and in the these are suppose these are the data set derived from your classroom, the height and weight of the students of a classroom. Suppose this is your weight and this is the height. Okay, suppose you get 40, 150, then 60, 170, then 70 and 180. In this case, do you notice a thing? The x is increasing, uh, the x and y is increasing at the same time. You see, when you have 40 in this part, you have 150. Then you have 60, then you have 170. The value of x and y are increasing. Then let's say, I'm going to give you another example, which is the number of hours you study, number of hours, um, and and the book you complete in these hours, the number of book you complete. So suppose the number of hours 2, 3, 4, and it goes like 7, 7, 3, 1. You see, the value of x is increasing, but the value of y is decreasing. Or similarly, you can say the value of x, if you start from here, the value of x is decreasing and the value of y is increasing. So actually what is happening, by covariance you get the quantity relation between two variables. So what is the takeaway from covariance? You get the quantity relation, between two variables. In this case, x and y. Let me make you understand by drawing some graph. It will be easy for you to understand. Let's suppose this is a x, y. This is your x-axis. This is your y-axis. X-axis, y-axis, x-axis, y-axis. So we have few types of covariance. One can be positive, one can be negative, or you can have no relation at all. So if you don't have any relation at all, the covariance will be 0. Yes. So covariance can be 0. Let me make you understand. Suppose the price of suppose the price of coffee has increased, and for the price of coffee has increased, the demand of tea has also increased. You see, the price of coffee has increased, and because the high price of coffee, people are tending towards tea. So the demand of tea is also increasing. You see, in this case, the X and the Y are increasing proportionally. So in for this, you can get a graph similarly like this. This is you can tell the graph is upward sloping direction, but let's say in this case, uh, suppose milk and tea. Since the price of milk has increased, so the demand of the demand of sugar has decreased. Or no, the demand of tea. The price of milk has increased, so the demand of tea has decreased, as people have to pay more to buy milk. So in this case, you get something like this as your graph, and you see this is downward sloping direction. The direction is downward sloping, and in this case your direction is upward sloping. And suppose in this graph there's no such relation. The data are distributed randomly around the graph, so you have no relation, right? For this example, we can tell the price of coffee has increased a lot, and in the in X you have the price of coffee has increased a lot, and in Y you have the price of pen has decreased in some manner. But you won't find any relation between these two, right? Uh, if you have your coffee's price increasing, you won't buy less or more pen. These are not correlated, right? There is no such relation. So in the correlation, in the covariance, we have positive covariance, we have negative covariance, and we have zero covariance. So in the positive covariance, the X is proportional to Y. In such case, the X is increasing, similarly the Y is also increasing, or the X is decreasing and the values of Y is also decreasing. Then you have negative correlation. In such case, your X is inversely proportional to Y. So your X is increasing and your Y is decreasing. And in this part, at time your X is decreasing, your Y is increasing. You have inverse relationship in negative covariance, and in zero relation, such no relation, there is actually no relation between X and Y. So what actually happens in covariance? In covariance, we understand the relation between X and Y, but there are some disadvantage of covariance. I think in 1 minute the meeting will be over. Just let me quickly tell you, there will be no limit, and you cannot find how much positive is your X or how much positive is your covariance or how much negative is your covariance. To fix this, we have Pearson correlation coefficient. So what was the problem in covariance? We cannot find the magnitude of relation. We cannot find the magnitude of relation. Guys, I have to end this session right here, as we don't have much time. I will cover the next part in the next session. So guys, if you have any question, please tell me. if you have any question. I guess yes, yes. You can get all the videos. These videos are being recorded. Once I'm done with the session, I will upload the videos. And if you have any question, you can ping me in my LinkedIn, or you can also find my socials. You can ask me there. And if you guys like today's session, uh, please come to the next session. And for today, I'm going to end this session right here because we are uh, getting out of time. And thank you everyone for joining. I think I went pretty fast on the last session, on the last topics, but I hope I will cover the Pearson correlation coefficient in the next session. And thank you everyone. Thank you for joining. Yes, this was from my part. Thanks a lot.